Good morning students. Today we will be performing the first practical, which is finding the pH value of these samples like dilute hydrochloric acid, dilute NaOH, dilute ethanoic acid, lemon juice, water, and all the things are lying here, and this is the pH paper. We will be testing all their pH with the help of the pH paper. You know, in this pH paper there are 7 numbers, and if the pH is less than 7, then it is an acidic in nature, and on the other side either you can find it is 8 to 14. If the sample solution is basic in nature, the pH will fall more than 7 to 14. Okay, let us test the different samples here. The first sample you can find, that is hydrochloric acid. Okay, let us test this pH of this hydrochloric acid. I just take out one pH paper, and this is the dropper which is washed in water. Now I'll just take a little amount of hydrochloric acid and put it on this. You can see there is a change of color. You can see the change of color. Now we have to just match this color in this to this pH strip. Okay, you can see that it is around 1. It is matching with this color 1. So the pH of this hydrochloric acid, dilute hydrochloric acid, it is around 1 to 2. So I will be just writing it, pH is coming 1. Okay, I am writing it here, pH of HCl. This is of HCl. Okay. Now the second thing is pH of the second sample which is given here, that is NaOH. Okay, let us check the pH of this NaOH. Again, first we need to wash this dropper, then we'll take you can see the color changes to blue. As you know, this NaOH is basic in nature. Let us check the pH of this NaOH. You can see it is coming around 13 to 14. The pH of this NaOH is coming around 13 to 14. Okay, it is coming around 13 to 14. Let me just write this NaOH here. The third sample. The third sample is of dilute ethanoic acid. This is ethanoic acid, acetic acid, that is a carbonic acid. I hope everybody knows the formula for ethanoic acid. Let us wash this. Now we'll check it. Ethanoic acid, CH3COOH is the formula for ethanoic acid. Any guesses about whether it is more acidic in nature or less acidic in comparison with HCl? Let us check the pH. In this pH strip, the number 2 is not there, but it is coming around 2 to 3. But the pH of acetic acid was coming around 1 to 2, and it is coming around 2 to 3. So any guesses about whether it is more acidic or less acidic than HCl? Yes, you are right. It is less acidic than HCl. So it is coming around 3 to 4. The next is water. Let us take this sample of distilled water. Now, the pH of this acetic acid is coming around 3 to 4. So what do you feel that which one is more acidic in nature? HCl or acetic acid? Yes, you are right. Acid is less acidic than HCl. HCl being inorganic acid, it gets completely ionized in water. That is why it is more acidic in nature, and it has a pH around 1. Okay, and what about the number of hydrogen ion in which in these two, in which the number of hydrogen ion will be more? Very good. Yes, the HCl contain more hydrogen ion concentration in it rather than this acetic acid. Okay, let us check then another sample, which is distilled water. Here is the sample of distilled water. I am writing here water. So you can see it is turning a light green in color, which is matching to 7. So what is the pH of water? That is 7. Let us write it. pH is 7. Next sample is, which is like lemon juice. For the lemon juice we have, okay, we have citric acid present in this beaker. Let us test this citric acid. Lemon juice. You can see this lemon juice also has the pH around 2 to 3. It is also coming around 2 to 3. Now next is dilute hydrogen carbonate. Hydrogen carbonate means here we will take the sample of sodium bicarbonate, that is also known as sodium hydrogen carbonate. So what may be the formula for the sodium hydrogen carbonate? NaHCO, sodium bicarbonate. Okay, let us just make the solution of it. Can this sodium bicarbonate give test? Can it change the color of the litmus paper in dry state? Very good. No, it cannot change because it is not get ionized until unless it is dissolved in water. Let us first dissolve in water, then we will check it. I am taking a test tube here. Make sure the test tube should be clean so that it should not change your result. I am adding a little amount of water into it. Now let us check it. Any guesses whether it will show acidic, basic or neutral? Yes, observe the change in color of this litmus paper. Let us match this. Is it 7? No, it is more than 7. Let us check it. It is coming around 9, 8 to 9. It is coming around 8 to 9. So being a salt, it should be neutral, but all the salts are not neutral. It depends on their parent acid and base whether they will show acidic property or the basic property. So this sodium hydrogen carbonate is a basic salt. Okay, here is the pH of this 8 to 9. I hope it is clear to all of you. Second part. Hello. Yes students, let us continue with the second part of this practical, that is studying the properties of acids and bases. Acid we are taking as acid and NaOH as a base. What are their reaction with, how do they change their color in acid litmus paper? We have already done. Let us discuss about how does this HCl and NaOH react with zinc matter. Okay. I am taking a little amount of HCl. Let me just take first zinc. It's the zinc granules. dilute hydrochloric acid. You can see the gas is coming out. वो matchstick चाहिए था. Release of gas, that is hydrogen gas. Let us test this. Okay, so it gives pop sound when we bring a burning matchstick near it. So which gas is this? This is hydrogen gas. As this hydrogen gas itself burn, it create vacuum there, and the nearby gases rushes to occupy that space, and that create pop sound. So when hydrochloric acid react with zinc, it gives hydrogen gas. I am writing the equation here. HCl react with zinc, it gives ZnCl2 plus hydrogen gas. This hydrogen gas gives pop sound when we bring a burning candle here. The next is, let us take the reaction of NaOH with zinc metal. This is zinc granule. Now NaOH, can you see very small bubbles? It is not reactive like HCl, but still there is a reaction happening. Only few bubbles. Okay, so here there is a gas release, that is also hydrogen gas. Let me just write this equation here. I am writing it here. Zinc reacting with NaOH, it will form sodium zincate, Na2ZnO2 plus hydrogen gas. That is a complex compound is being formed here, and there is a release of, but this reaction is not a vigorous reaction like that HCl and zinc. Okay, now let us check how does this hydrochloric acid react with sodium carbonate. Here we have sodium carbonate. Okay, let me just take first hydrochloric acid in this test tube. Hydrochloric acid. Now you can see the bubbles coming out. Now let us check whether which gas is this. You can see that the mastic has put off. It is due to that it is not hydrogen gas, it is carbon dioxide gas which does not support burning. That is why it extinguishes fire. Equation of HCl with sodium carbonate. This is HCl. When react with sodium carbonate, yes students, due to the presence of this carbonate anion, it will be releasing carbon dioxide gas. So it will be making, as you know that it is an acid and this is a basic salt. So acid and bases react and they give rise to salt and water. So what salt will be formed here? NaCl and water, and additional carbon dioxide gas will be released, that you have seen this in this experiment. So whenever in the product if there is a carbon dioxide, it means as an anion there must be carbonate. Okay. Now let us check the reaction of NaOH with sodium carbonate. Any guesses whether they will react or not? Yes, they will not react because both are basic in nature. This is NaOH I am taking in this test tube. And this is again sodium carbonate. sodium carbonate is a basic salt. So both are basic in nature. You can see there is no reaction happening here. Okay. Okay, so I hope students it is clear how to just check the pH with the help of the pH paper, as well as how does this HCl react with litmus, zinc and sodium carbonate, and how does this NaOH react with zinc and sodium carbonate. You must have observed that zinc react with HCl and NaOH both, and in both the cases hydrogen gas is released. Okay, when acid react with sodium bicarbonate or sodium carbonate, due to the presence of this carbonate anion, it releases carbon dioxide gas which extinguishes fire. Thank you.